Hey, so I thought to go through the main workflow in the software. That will essentially be going from the top here to the bottom, typically ending in the numerical model feature. What I need to do that is to find the relevant field that I'm working in, then just go to the project where I have the wells that I'd like to work on. And in this example, I'll be looking at this particular Eagle Ford well right here. So the first step in the workflow is to get your PBT initialized. To do that, you open the reservoir fluid composition card right here. And there's different methods depending on what kind of data you have available. The method that I'm going to use in this example is the so-called GOR method. So if I zoom in a little bit, you can see that after around 25 days, the GOR is kind of stabilized like this, but after a while it goes below the saturation pressure and gas is coming out of solution. So how do I initialize and what should I really do here? Well, you could either use the drag and drop functionality like this, where you drag and drop this line up and down. That's of course also linked to this number right here. So I can make this 500 and you see the line is changing, or I can make it 1500 and you see the line is changing as well. But in this case, I'm kind of a round numbers guy, so I'll just keep it and make it 750. Click save, and the software will go in and predict the fluid composition for you, all the way up to C30 plus, which is this compositional slate in this particular example. It uses that to create the space envelope we see right here. And it automatically creates the PBT tables that you can either export into any third-party tool, whether that's being Eclipse, ResFrac, just Excel, and any of T-Navigator, etc. Or they're automatically used anywhere inside of the software where you need PBT properties. And again, just to emphasize that, behind the scenes here, there is an equation of state model. This is just a default equation of state model that's used in the tool if you don't have your own, but you can also very easily update your own equation of state model as well with just drag and drop functionality too. So once you have your PBT set, you're ready to upload production data. In this case, we have production data for 3 streams, oil, gas, and water. You can do that manually by just copying and pasting from an Excel spreadsheet, or you could import it through a mass upload template, so basically a CSV or an Excel template, or probably the most sophisticated is to have the API integrated. And what that will mean is that if I went to dates here and I looked at the end of history, or I looked at the end of history date right here, it will be 25th of December or whatever day it is. The day you've been connecting and updating the data. So once you have production data on PBT, you could, for instance, go and do some declines. I'm kind of a decline guy. I like to do that first just to get some rough numbers in the back of my mind. There's an autofit function right here that's being run automatically, but you can overwrite that as you like, either with drag and drop functionality like this. This is in rate cube space, but you can of course also do it in rate time space as well. And this is just a one segment with or like a modified ARPS, but you can add multiple segments if you would like to do that as well. Once you have production data and PBT, you're ready to calculate your bottomhole pressures. To do that, you just need your well deviation survey, and you need to build your well bore versus time. In this case, we have 2 different well bore configurations over time. So initially the well is flowing through tubing only, and then we're activating gas lift. The software can accommodate for any flow path, casing, tubing, analysis, etc. Any type of lift method. Also for gas lift, you can use either one of the valves or all of the valves versus depth, depending on what type of gas lift system you're dealing with. In this case, there's only one valve in the system, but if it was more than one valve, we could also account for all of those valves. You can compute the bottomhole pressure through the flowing side and the static side. Once you're happy with that, you click save, and then once you would like to actually run the calculation, you just click the button up here to the left, and it's a really fast calculation that calculates 4 different correlations at the same time: Baxter, Bill, Hagen and Brown, Wallace, Martin, Gayar, and Gray. And then you need to tell the software which of these correlations that you like to use. Would you like to use Beggs and Brill? Would you like to use Hagen and Brown? etc. This can be set, manually one by one for each well, or you can set it for all the wells at the same time. I'll get back to some of that mass kind of bulk load and bulk run functionality. So once you have PVT and bottomhole pressures, so now I'm basically saying that I would like to use Voltsmart and Gaillard, I'm ready to do the workflow. What is very popular to do in the tool is to use what's called custom bottomhole pressures. That means that you can smooth out a stream. So I can take the gauge pressure in this case and smooth it out with different sampling frequencies. I can also go in and delete points that I don't like by dragging them below the line here. I can also lasso remove points that I don't like. Here it actually looks pretty good, and I can click save, and then I'll be able to use that smoothed bottomhole pressure right here, because many times the spikes in the data, they're just associated with bad water readings or pressure readings. So once I have this smoothed bottomhole pressures, if I went into the numerical model, for instance, you'll see that custom bottomhole pressure number is what's being imported here in my final step. We'll get back to that in a sec. So now I have PVT and I have bottomhole pressures, and I'm ready to run my flow material balance. In this case, the flow material balance, you'll see it's a little bit different than maybe what you used to before. It goes up and to the right and not down and to the right. And the reason for that is that it actually makes the late time points, which is typically the most important, easier to read. And it's very easy in terms of a flow material balance exercise. You're only trying to estimate the size of the tank. So this will be a small tank, this will be a big tank, and this will be an even bigger tank. Okay, and you can see that up here to the right. So when I say small tanks, if I make this 300, it looks like this. If I make it 700, it looks like this. And if I make this 1500, it looks like this. And for this example, it looks like the shallowest absorbed slope on the screen here is around 800 MSdB. And I would like to make sure that this should be a conservative estimate, because these flow material balance techniques, they assume boundary dominated flow. So I should always use this at my lower estimate before I go into analytical RTA or my numerical model. The analytical RTA dashboard will look very, very similar to what you're used to in other softwares. The main part of the workflow is, of course, the square root of time plot, where this line right here is what gives you your A root K. And then this time to interlinear flow right here is what gives you the time to interlinear flow, or basically the size of the tank. So you can go in here, you can click AutoFit, and the software will come up with some default fits for you. And you can also go in and add slopes as you like. So this is just a quarter slope before you go into a half slope, and then eventually maybe what looks to be a boundary dominated flow. And there's a lot of other functionality here, for instance, using integrals and derivatives and whatnot as well, that can help you assist what flow regime you're in, especially before you go into the numerical RTA numerical model, which is kind of the last step. So, very briefly, what's the difference between analytical RTA and numerical RTA? It's just that the analytical RTA gives you the A root K and the contacted pore volume analytically, assuming one phase. While in numerical RTA, you're actually using all the different phases. So and it's a true multi-phase, and it kind of solves that inherent problem that you typically get once you combine multi-phase flow effects and superposition. But the concept is the same. You're trying to find a root K, and you're trying to find the size of the tank. And the way it does that with the numerical RTA is that you use this key diagnostic plot right here. The straight line gives you your A root K. So when I move that straight line up and down, it gives me my A root K. And you can say that if I'm very far away from this actual production data right here, you'll see that my cumes will be very badly fitted as well. The ratios will always be good. But if I make this a better fit, something like this, you'll see that my A root K is around 62, and my contacted pore volume is 860. And I can also hold in control and click this, and you'll see that I'll have basically a perfect history match numerically on both cume gas and cume oil when I bring this into my final step, which is the history match. So to do that, I'll just click export here. And my final step would be this history matching model right here, where my forecasted or where my historical history match is really good for both oil, gas, and bottom pressure. And also the stabilized cumes that you see here after the flowback data has been produced back is also decent. Maybe I could have lifted those up a little bit. And then the last part that is needed in the workflow is to append a forecast. Here I just forecasted this for 10,000 days, and that's what you're looking at right here. So, you know, an EOR for this well is around 180. And then I can go up to the right here and say, okay, how does this actually compare to my DCA EOR? So my DCA EOR here looks like I had 162, and here I had 178. So maybe I either go back to the DCA and then adjust it up a little bit to make sure I have something consistent. So that kind of sums up the base workflow. In addition to that, there's a ton of other functionality related to diagnostic plot, type well workflows, nodal analysis, well tests, and whatnot. I'll skip that in this short intro. And this is kind of the core RTA workflow that most of the people are running, at least from an RTA perspective. And very important to emphasize is that you can go in and actually run it for a wide range of wells at the same time. So you can go in and bulk run, for instance, the PVT, your RTA autofits, your numerical models, your numerical RTA models. You can also bulk edit. Let's say you would like to set all the correlations to be using gray. You can do that easily. And you can also bulk run all the numerical models as well if you want to. Same with the bottomhole pressures and whatnot. So that's a little bit of a kind of a broad introduction, and happy to answer any questions you might have that goes beyond this.